Selamat sejahtera. Today, me, Nur Izzurin binti Muhammad Syami and Muhammad Imtiaz will be presenting about tensile strength test. Step 1 on tensile test on mild steel, we measure the initial diameter of the tension test sample in two perpendicular directions using vernier calipers. And the distance we get 12.47. Next, step 2, measure the length of the specimen between the grips using a scale. Then, step 3, punch marks are made at a distance of 2.5 diameter. So, distance between 2.5 diameter, we got like 12. We times it by 12.47. So the distance between the first punch mark and the third punch mark was 31.80 millimeter. So the fourth step, insert the specimen into its position and mount extensometer on the specimen. And then step 5, readings on the dials A and B of extensometer are adjusted to 0. So the least count of extensometer is 0.01 millimeter. The next step is experiment is conducted. Low extensometer readings are read at the regular intervals of load up into the yield point. Average scale readings are noted till the specimen failure. These are the data. These are the load versus ivory scale reading. And these are the data that we can collect from the experiment. This is the load versus extensometer reading. This graph is to find the slope. Step 9. Join the two pieces of the test sample and measure the diameter at the neck of the specimen. So the final diameter is 8.46 millimeter. Step 10. Measure the final length between the three punch marks. So the final we get is 86 millimeter. So we can do calculation later. So this is the graph, load versus ivory scale reading. As you can see, the maximum load here is 52.5. These are the tension data. As you can see from the experiment just now, you can get the initial diameter, length of the specimen between the grips, final diameter, final length, punch mark, original area, final area, least count, and gauge length of the extensometer. Alright, this is the formula for calculation. To find yield strength, we have to find the load of yield point, and then we divide it by the original area. The next formula is tensile strength. We take the ultimate load or maximum load and we divide it by the original area. The third formula is the modulus of elasticity. We take the slope and then we times it by the gauge length and we divide it also by the area original. Next, we need to the formula for the percentage of elongation. We need to take the final length minus initial length and then we divided it again by initial length and we times it by 100. And last formula is percentage of reduction area. We take the initial area minus final area and divided it by the original area and then times it by 100 to find the percentage. So as you can see here, it's a yield strength. We take 37.5 and we divided it by 119.54 and times it by 1000. Why do we have to times it by 1000? Because we need it in Newton, not kilonewton. So we do the calculation, we get 330.70 Then next, tensile strength. We take 52.5 minus 119.54 and times it 100 by 1002, and then we get 439.18 Newton millimeter. Next, modulus of elasticity. We take the slope, which is 2.08, and we times it by 120 and divide it by 190.54. Next, after we get the value from the calculation above, we times it by 100 and we get it 208.80 GPa. Next, the percentage of elongation, 87, open bracket, 31.34 times 2 close bracket, divided by 21.34 times 2, and then from that value we times it by 100 and we get 38.8%. Percentage of reduction area, we take 119.54 minus by 52.91 and we divide it by 190.54, and the value from the above we times it by 100 and we get it 55.74%.
In tension test, ends of a test piece are fixed into grips connected to a straining device and to a load measuring device. The test involves straining a test piece by tensile force, generally to fracture for the purpose of determining one or more of the mechanical properties. The straining unit of universal testing machine consists of main hydraulic cylinder with robust base, inside and piston which move up and down. The lower table connected to main piston through a ball, and the ball seat is joined to ensure axial loading. There is a connection between lower table and upper head assembly that move up and down with main piston. The control panel consists of a power pack complete with drive motor and an oil tank, control valves and an orthographic recorder. Load indicator system consists of a large dial and a pointer. A dummy pointer is provided to record the maximum load reached during the test. Load is applied by a hydrostatically lubricated ram. Main cylinder pressure is transmitted to the cylinder of the pendulum dynamometer system housed in the control panel. The cylinder of the dynamometer is also of self-lubricating design. The load transmitted to the cylinder of the dynamometer is transferred through a lever system to a pendulum. Displacement of the pendulum actuates the rack and pinion mechanism which operates the load indicator, pointer and the orthographic recorder. The deflection of the pendulum represents the absolute load applied on the test specimen. Return movement of the pendulum is effectively dampened to absorb energy in the event of sudden breakage of a specimen. For the first result is yield stress. Actual value is 342.98. Entered value is 313.70. Percentage error is 8.54. Second is tensile strength. Actual value is 485.19. Entered value is 439.18. Percentage error is 9.48. Third is modulus of elasticity. Actual value is 209.1. Entered value is 208.80. Percentage error is 0.14. Fourth is percentage elongation. Actual value is 38.8. Entered value is 38.8. Percentage error is 0. Lastly, percentage reduction in area. Actual value is 55.74. entered value is 55.74 and percentage error is 0. Tensile strength is one of the most commonly used testing procedures in a wide range of industries. It is meant to determine the tensile strength of the materials which are used in the industries for manufacturing of distinct products. For best quality analysis, it is essential to obey the strict specification given in the standards while conducting the tensile test. Some of the precautions that must be taken while performing the test are: first, the grips used in testing machine must be properly serrated so that there is no chance of slippage of the specimen. Secondly, if the specimen breaks due to any reason other than the tensile stress, the test procedure should be discarded, and a new test must be performed on a fresh specimen. Thirdly, the thickness of the specimen should be according to the related standard.